And like I said before, in simplest form, you will want to have everything in lowest terms. In fractions, like we said before, 4/6 you would like to write as 2/3. So in part A, we'll do A first. Do you see that you have a fraction? You have a 25 and a 35. Draw my line there. Can you simplify that? Right? What would that number be in lowest terms? You could divide both of them by 5, right? So can you see that you would have -5/7? That'll be just the numbers. With exponents, you can do your exponent laws, okay? Which my hope is you can just write the answer down right away, okay? If you can't see the answer right away, I'm going to show you some things about this that maybe can help, okay? So first of all, the -5 and the 7, everybody's okay with that with numbers because that's what we've done before, okay? Now with the a cubed and the a on the bottom, I hope you can see that that would become a squared at the top. If you can't, I'm going to do an extra step up here. I'm going to rewrite my a cubed as a times a times a, my b squared is b times b, and my c is just a c, and on the bottom I have an a, and b times b times b times b times b. I could do that. If I did that, does it make sense that a divided by a is 1? So I put a line through those to say, that's 1. Anything else 1? Yes. B divided by b is 1, and b divided by b is 1. If I write it out like that, what am I left with? I'm left with just 2 a's up there. That's still a squared, right? On the top, you see I'm also left with a c. And if I have b squared on the top and b to the 5 on the bottom, does it make sense that I have 3 b's left on the bottom? Sometimes, though, writing it completely out as its factors is helpful. Now, some important things about simplifying. We can simplify something to equal 1 only if the factors are identical and only if you're multiplying. Okay? Look what happens if you're adding. 3 plus 4 divided by 4. This is bad if you do this. It is not equal to 3 plus 1 divided by 1. 3 plus 4 is 7. Last time I checked. I would have 7 over 4. 7 over 4 is 1.75. 4 over 1 is not 1.75. It doesn't work if you're adding. It only works if you're subtracting. It's really easy to see when you use regular numbers, and it makes complete sense to you why you wouldn't cancel out those 4s. Your brain automatically says, no, 3 plus 4 is 7. 7 divided by 4. But as soon as we change to algebra, your common sense goes out. It's like, you will start canceling things you're not allowed to cancel. Okay? So, very important, if you're adding, which we're going to do in part B. And you will succumb to some mathematical temptations. You'll be like, ooh, 6 divided by 3, I want to make that 2. No. You are not allowed because of the adding. Technically, whenever something is adding, that gets grouped together and is one big factor. And the only way we can simplify is if we have that identical factor on the bottom to make 1. But I don't. So what do I do in a situation like this? Well, I want to factor. If I look at the top, I have something in common. I can pull out a 6, and I can pull out an x, leaving me with x plus 2. And on the bottom, I have a 3 and an x. So first of all, I'm going to add some purple dots to say this means 6 times x plus 2. And the bottom means 3 times x. So on the top, I have 3 things multiplied together. On the bottom, I have two things multiplied together. First of all, can you see that the x's now are identical? They could simplify. That would be allowed. Secondly, the 6 and the 3 now are multiplied. I could reduce that. Sometimes people even like to say, like, technically what you could do with the 6, can you see that you could change that 6 to 3 plus 2? Nobody ever shows this step. Can you believe that 6 is 3 times 2? And now these are identical, so they could cancel out? Most people would just skip this step and say, well, if I'm multiplying and I have numbers, 6 divided by 3 is 2. And that would give me 2 times x plus 2. Does the answer key leave it like that, or do they write 2x plus 4? No, they leave it factored. Okay? When you do look at the answer key lists all the non-permissible values. So in the first one, can you see that A can't equal 0 and B can't equal 0? They list that in the question. In the second one, what can't equal 0? The second one in B, they would put a comma and they write, just letting you know, this is simplified, but if we go back to the original equation, there was a non-permissible value, that x couldn't equal 0. So sometimes you have an original equation with a non-permissible value, but it simplifies away, and now you have a new equation. And the new equation, technically 0 is allowed, but because the original equation, you weren't allowed to use 0, you still have to write, oh, and by the way, x can't equal 0. C. We're adding and subtracting. Can I cancel out those x squareds that are so tempting out in front? No. Because right now, the top, we would have to think anytime things are connected with adding and subtracting, they become one factor. And the only way we can simplify is if those factors are identical. However, I can factor the top as a difference of squares. Right? Now I have a dot right there. Now I have two factors. I can factor the bottom. Has to be 7 and 2 for 14. The 7 would be negative, the 2 would be positive. And now this is two factors. Are any of them identical now? Yes. So we can cancel those out. And this simplifies to x plus 7 over x plus 2. Did we have any non-permissible values? When we looked at our original factored one, can you see that x couldn't equal 7? Oh, yeah, that's weird. Can't equal 7, and x can't equal negative 2. So if we factor, then we get multiplication. And if two factors are the same in multiplication, they can be simplified to 1. They can't be simplified to 1 in adding or subtracting. Only in multiplication. I mean, what was our... You never do this, but remember how, what did we start with, 25 over 35? Right? You could if you wanted to. Do you realize that 25 is 5 times 5? And 35 is 5 times 7? You could change it to multiplying and go and get 5 sevenths. But all the way along in math, you've just been taught, oh, is there something you can divide both numbers by? And the answer was 5, so you did that, right? But really, what you're doing by dividing both by 5 is you're saying, hey, I could write 25 as 5 times 5, and 35 as 5 times 7. And then my 5s will cancel out and give me 5 sevenths. If you want to do that with the numbers, you can do that as well. We did that, you see we did that with the 6 and the 3. The 6 and the 3, they both could be divided by 2. But we could have written 6 as 3 times 2. Yes.
But why couldn't x equal 7?
Because in the original equation, right here, right, before I simplified it, it would still, right, it would still, if I went to this original equation, I plugged in 7. 49 minus 35 minus 14 is 0. Boom. The bottom explodes. Right? And this is what happens if you do that at your house. Your house implodes like this. Check out that poster for someone who tried to divide by 0 at home. So let's do our last one here. We'll do it in glass. Right, this right now is all grouped together. This is all grouped together. Are they the same? No. Ooh, this last one's going to have some fun. So I'm going to teach you something kind of neat. So first of all, I factor. The bottom looks easier to factor. It's the difference of squares. Can you see that it will be 3 plus x and 3 minus x? Everybody good with that? Top, a little bit harder. It's going to have to be 2x and x. Now, can you see to get 3, it's either 3 and 1 or 1 and 3. This unit is terrible for giving hints away. Do you think that they would want us to factor and not be able to cancel anything out? No, all the fun in this unit is canceling things out. So I'm pretty sure the 3 is going to go here with the x. Because I'm thinking things want to cancel out. But let's check it. So the 3 is there, this is a 1. I want my outside and inside to make minus 5. Then they would both have to be negative. Does it still? No, that doesn't work. Because if they're both negative, I get a plus 3. Let's see. This would be negative 6. Oh, negative 6 plus 1 would give me negative 5. Again, very important, after you factored, to multiply it out in your head to check if it worked. Right? I quickly made an assumption, hey, they should both be negative, but when I checked, I was like, oh, that doesn't work. How do I adjust that to make it work? Are any of the factors identical? No, they're not. Like, is x minus 3 identical to 3 minus x? Like, plug in 2, are they the same? No. So this one, well, I got excited about this one. Special note. Did you know that 3 minus x, if you take out a negative 1, if I take out a negative 1, do you see that the 3 would become negative? And if I take a negative 1 out of a negative x, the x would become positive. So factoring out a negative, oops, wait a minute. Factoring out a negative would make the 3 negative, the x positive. So we're going to go back to our equation, and on the bottom, we'll keep the top the same, 2x plus 1 and x minus 3. And on the bottom, I'm going to keep my 3 plus x, but now I'm going to factor out a negative 1. And by doing that, I do get something that's identical. So you'll notice that whenever you have these but flipped, you can make them the same by factoring out a negative. And you can see why that happens by plugging any number in for x. Plug in 10. Let's just look at x minus 3 over 3 minus x. If x is 10, can you see that I would get 7 over negative 7, which is equal to negative 1. Okay? Plug in 23, using it twice in one class. 23 minus 3 would be 20. 3 minus 23 would be negative 20. That will give me negative 1. I was going to pick 1 million. I'm going to have to be like 999,997 on the top, and 3 minus a million is negative 999,997. You'll get negative 1. So when we factor out that negative, notice those will simplify now. And what are you just left with? The negative 1. Now, I would be fine if you left it like this. Okay? I would be fine if you decided to put that negative out in front. Because a negative 1 on the bottom of the fraction is the same as a negative 1 on the top of the fraction. It's the same as a negative 1 out in front of the fraction. It's the same as you deciding to distribute the negative 1. So if I put this negative 1 into the top of my fraction, I get negative 2x minus 1 over 3 plus x. That is also the same. It's good to know what things look like when they're the same, especially on multiple choice questions of tests, because you came up with this answer. The multiple choice has this answer or this answer. We need to know how to manipulate something no matter which way it is. What did they do? Oh, they put the negative out in front. Right? We could have left the negative 1. I'd be happy if you left the negative 1 on the bottom, or if you left the negative 1 on the top, or if you distributed it. Either of those ones would have been fine. Right. This question is sponsored by Slurpee. Circle question 7 and 11.